Hey everybody, welcome back to Organic Chemistry. My name is Todd Rothman. In this video, we're going to go over the anti-additions. Okay, so at this point, we've learned about anti and syn addition reactions, and that's when you can have all different types of stereoisomers. We've also talked about regio and stereo-specific reactions and all the things that go along with that. In this video series, we're going to focus in just on the anti. And so as you can see, there's only 3 reactions that we need to know from this category. Let's get started. So the first one is, the halogenation reaction. And this is where we're dealing with X2. Okay, so X2 can be like Br2 or Cl2 or I2 or even F2. Okay, but it can be a combination of Br and Cl or Br and F and Br and I and so on, Cli. So it doesn't have to be the same halogen twice, but at a minimum it's going to be 2 halogens. And so if we have an alkene and we react it with, let's say, Br2 to begin, now the solution is going to be either CCl4 or CH2Cl2, something that's aprotic. Again, the solution is very important, as you'll see in the next reaction. Okay, so in this case, the solution is not going to be involved with the reaction at all. Okay, now the way this happens is it's an anti-only addition, and the signature for all anti-only is that you make a triangle intermediate. You do not make a carbocation. So one thing to note about all anti-additions, so let me actually put this on the page before, all anti-additions make a triangle like that. Okay, and the positive is on the triangle, it's not on the carbons. So this means that there's no rearrangement. Why? Because the carbon is never positive. If there's no carbocation, then there's no rearrangement. Okay, so this is something that we should know about all anti-additions. Okay, so let's what's that say? Make triangle. There you go. All right, so let's go back to our reaction. So what's going to happen here is the double bond is going to come in. It's going to pull off one of the 2 BRs. And when the BR comes in, it makes this triangle. So the idea here is that initially it comes in just like all the other ones did. It would go to the lower degree. But because, so let's actually, let me show you what that looks like. So the BR initially comes in like that, and this would be positive. But because the BR has lone pair, it has 3 lone pairs, and the carbon's positive right next to it, it gets sucked over into that position. So the BR winds up giving its electron to the neighbor, and so what you actually draw is just that right there. So the BR makes this triangle, making it in turn positive because it lost an electron. By doing that, it gave carbon one of its 2 electrons. And so here you have this right here. This is known as a bromonium ion. So it could be bromonium or in general hallonium ion, and that just simply means that you have a halogen that's positive. Now the next thing that happens is the next BR is going to come in, and because the BR is blocking the top, it can only come in anti only, because the BR is on top, which means that this must come in from below. But another thing to recognize is the same pattern as always. The first group that comes in, it winds up on the lower degree, and the second group winds up on the higher degree. Here's the logic. This BR is going to open up slightly faster than the BR coming in. And so if it opens up away from the higher degree, then that means that this BR can go to the secondary, right? This is secondary and primary. So the next one goes into the higher degree because it becomes positive for a moment before the BR fully connects on. So what we wind up getting is we get a BR here and another BR there. And that's the anti-addition. Okay? So just like always, if we make a stereocenter, we have to identify the wedges and the dashes, and we'll go over that in just a few. But for now, let's just get the general mechanism down. So this is the idea of the halogenation reaction. You can bring in the first halogen, and then the second one comes in, and it goes to the higher degree. Now, I want to point out another important idea. Let's say, for example, 2. Let's say I have a ring system, for example, and I write BrCl. So this is two different halogens. Who comes in first, who comes in second, right? So let's say this is in CH2Cl2. Well, here's how you figure this out. The way this works is the BrCl, you have to think about who's more electronegative. And in this case, it's Cl. Remember, electronegativity increases going up the periodic table. So if this is our groups, it increases up this way. So Cl is more electronegative than Br. What that means is that Br is more positive and Cl is more negative. So when you think about who comes in first, it's always the positive first. So we would wind up getting the Br to come in, and it would actually come in two different ways. Either it comes in on the wedge, like that, making a triangle, or it could have come in from the back, like that, making a triangle. So one of these two, they actually both happen. It's whether the Br lands in from on top or it comes in from below. Either way, it's blocking a whole side from the next group coming in. So they both happen. That's number one. You get both of these answers. But now let's think about what happens when Cl comes in. So when Cl minus comes in, what happens next? Well, first of all, let's put a branch. Let's put a branch right there. So now if the Br is on the wedge, the branch is in the back. And if Br is in the back, the branch is on the wedge. So now we have a difference of degree, right? We have a tertiary and a secondary. So tertiary and a secondary. So when the Cl comes in, it can come in both of these cases, but opposite side, right? So it's going to go to the higher degree, tertiary. The Br leans away, secondary. Higher degree, tertiary. Br leans away, secondary. But it comes in opposite side of Br. So it's an anti-only addition. So if Br is on the wedge over here, because it leaned away, then the Cl's in the back. And by default, if Cl comes in on the back, then that means that that methyl that's up there is on the wedge, because that's the only bond that's left. So you see how we figured that out? Okay, same thing here. If Cl comes in from the wedge, in this case, because notice how the Br is in the back, so Cl has to come in on the wedge. Well, Br leans away from the back, and now Cl's on the wedge, and then where's that methyl? Well, again, the default, what's missing is a back bond, so that's where the methyl must be. So the methyl is in the back. All right, so that is how you cover this reaction. So I showed you, number one, a general template that did not include stereochem. It wasn't necessary in this particular example. Not to say there isn't chirality, but we'll come back to that. But here I did show you, for example, two things. I showed you how to deal with stereochem, but I also showed you how to figure out which halogen comes in first, and then that in turn means it winds up on the lower degree. Remember, the first one in always winds up on the lower degree at the end of the reaction, no matter what the reaction is, okay? And that's what we're seeing here. All right, the next reaction type is called a Hallow Hydrant. This is what's known as a competition reaction. This is a competition reaction. The reason why it's a competition is because we have a solution that's going to compete with the halogens. So let's say there's a Br2, and this is in, let's say, some sort of protic solution. So we have a protic solution. So it could be any protic solution, OH or NH, right? Doesn't matter. So let's say this is methanol. Now, this is the difference. The first part's the same. We're going to break the double bond. We're going to bring in the Br, and the other Br leaves. We make a triangle. Carbocation, bromonium ion, right? But now here's the competition. We have a Br minus, but we also have CH3OH, the solution. Now think about this. You have this bromonium ion, and it's completely surrounded by alcohol. So another Br minus has to travel over and attack, but alcohol's everywhere. So the solution always wins. Solution wins as the major product. What that means is you can get some Br in as a minor. Maybe by chance it happens to be close by. But the most important thing that would happen is the solution comes in. So it's the same idea. The solution comes in, it goes to the